That you assigned yesterday, 6-12. Alright. So, what we're going to start with is a free body diagram. You can't do anything without that on this problem. So the first thing I'm going to do is I am going to redraw relabel, D, A, C, B. And now I'm going to put in the forces that we need. So the reaction force at a pin, which would be right here, is a force in the X, call it FCX, and a force in the Y, which I'm going to draw this direction, FCY. The reaction at the roller B is just going to be in the X direction, call it FBX. And then I have a force going down. It had a value of 100 pounds. And I had one to the right with a value of 240 pounds. Everyone with me so far? Sorry. All right. Now, this problem told you that you didn't actually need the external forces. It said you just need to find the internal forces. So there is a way, if I look at this problem, I can break it down to just use internal forces. I just have to be smart about where I'm going to go. So I'm going to start looking at this problem, and I'm going to go with the easiest joint, joint A. I'm going to redraw the free body diagram for joint A. This is FAB, and this one is AC. Everyone with me? Okay. I'm going to do like I always do. I add forces in the X direction. They need to equal 0. So I'm going to have negative AC, because it's moving to the left. But all of AC isn't in the X direction. Part of it is in the Y direction. So what I look at is the total length of the hypotenuse of this triangle. If I pretend this is a right triangle, the total length of this can be calculated. Using Pythagorean's theorem, you do 12 squared plus 5 squared, you get 13 is that length. So the total is 13. The part that's in the X direction is the length of AB, and it is 12. The next thing I have is minus AB, because it's moving to the left. I don't have anything else in the X direction, so that equals 0. Okay? I go on to my next equation. Sum of the forces in the Y direction equals to 0. The only thing I have is AC. It's going up, so I leave it as positive. But it's not all of AC again. It's the part that is in the Y. That's 5 over 13. There are no other forces in the Y direction. So AC times 5 over 13 is equal to 0, which tells us that AC is 0. If I take that and I plug it into the previous equation, I get 0 minus AB equals 0, which means AB is also equal to 0. Now I got to pick another joint. I'm going to go to joint D next. I go to joint D because it's got numbers and it's only got 2 members on it, right? So you look at joint D. So this one was 240 pounds. This one is 100 pounds. Over here, this is BD, and this one's CD. That look about right? Yeah? All right. Some of the forces in the x direction again. It has to equal to 0. I have negative CD. I have minus BD. But again, BD is going, it's going left, so it's negative, but BD isn't all in the x direction. Only the x part, which was 12, over the total part, which was 13, is. Plus 240 equals 0. I go on to the next one. Some of the forces in the y direction equals to 0. I have 100 going down, so minus 100. And I have BD going down, so minus BD. Again, it's not all of BD, it's just the part in the y direction. So 5 over 13 equals to 0. Move 100 to the other side of the equation. Divide by 5 over 13, you should get BD is equal to 460, I think. Anyone going to confirm that for me? 260?
260.
240? 260? All right, BD is equal to 260 pounds. But it's a negative. There's a negative on this. That means it's 260 pounds in compression, because we always draw them in tension, unless we know better, in which case we can put it in compression. Now when I plug that negative 260 back into this first equation, I'm going to keep it as a negative, because that's how I drew it and that's how I put it into the equation. So I put negative CD minus negative 260 plus 240 equals 0. That means CD is equal to, what's 240 plus 260? 500 pounds. And I drew it in tension. I got a positive number. That means it's in tension. All right. We're almost done. We've got one more thing to solve. And that's going to be CB, or BC. So I'm going to go down to joint B. Joint B had a force going this way. It has a force going that way. It has a force going that way. And it has a force here that we said was FBX. This was AB. This was BD. And this was BC. BC is the only one we need to solve for, right? Okay. I see it's in the y direction, so I'm only going to do some of the forces in the y's this time. Okay, so I've got BC, and I've got BD drawn going up, so that's going to be plus BD, but only the part of BD that's in the y direction, that's 5 over 13. That equals 0. We've already solved for what BD is, though. BD was 260 pounds in compression. I drew it in tension again. So that means I need to put BC minus 260 times 5 over 13 equals 0. So we should get BC is equal to 100 pounds in tension. Go back, make our table. we should have AB AC, BC, BD, and CD. BC was 100 pounds tension. CD was 500 pounds in tension. BD was 260 pounds in compression. AB and AC were both 0. That's it.